So let's begin with using reduction formula for integrals of the form x raised to power n exponential x with respect to x. So let's see integrating x raised to power n exponential x with respect to x. The question still remains, what is our u and what is our dv? So this is arithmetic and this is exponential. So considering like x as we have been doing, we realize that this a will be our u and the exponential will be our v. So u is will be x raised to power n and our dv dx or dv is x exponential x dx. So in this case, we'll have to evaluate the u, and the u dx in this case is nx raised to power n minus 1, and therefore the u will be nx raised to power n minus 1 multiplied by dx. Now, in the case of dv is equals to exponential x with respect to x. Therefore, our v will be equals to integral of exponential x with respect to x, and integrating exponential x, we will have exponential x. Therefore, let's apply integration by parts formula that says integral of u dv is equal to uv minus integral of v du. Therefore, integral of exponential n integral of x raised to power n exponential x dx is equals to u. Our u is x raised to power n, and our v, which is exponential x, minus integral of our v. Our v is x raised to power x, and our du is nx n minus 1 dx. Now this will be equal to exponential n x raised to power n exponential x. N is a constant which can be brought outside, and we have x raised to power n minus 1 exponential x dx. Now the integral on the far right is seen to be as the form is seen to be of the same form as the integral on the left hand side, comparing x raised to power n exponential x dx. So this is similar to this, except that n has been replaced with n minus 1. So therefore, if we say that, let's represent in to be equals to integral of x raised to power n exponential x dx. Therefore, in minus 1 is equals to integral of x n minus 1 exponential x dx. So if we make our substitution using in, we can see now that this becomes in is equals to x raised to power n exponential x minus n in minus 1. Now this formula here is called the reduction formula for integral of x raised to power n, reduction formula for x raised to power n exponential x dx. Now let's take an example. X squared exponential x to be integrated with respect to x. Now recall that the reduction formula of x raised to power n exponential x dx is given as in which is the same thing as x raised to power n exponential x minus n in minus 1. So if we compare what we have here to this, we will realize that our n is equal to what? 2. Therefore, we have that our integral of x squared exponential x dx is equal to I2, which is equals to x raised to power 2 exponential x minus 2. Okay, wherever we see x, n, we substitute 2 into I substitute 2 minus 1. And 2 minus 1 is the same thing as what? 1. So we have reduced the weight of the problem to just evaluating I2. Now, in the expression of I2, we can see that there is I1 present. So we have to find an expression for I1. Following the formula that In is equals to x raised to power n exponential x minus n in minus 1, then I1, that means we are saying that n is equals to 1. Wherever we see n, we substitute 1. It will give us x raised to power 1 exponential x minus 1 I1 minus 1. Therefore, I1 is equals to x exponential x minus I naught. In I2, we had an expression for I1, and we have been able to evaluate, deduce the formula for I1. And in the formula for I1, we can see that I naught is present. How then do we evaluate I naught? Let's follow this one again. And when n is equals to 0, we have that I naught is equal to exponential 0, x raised to power 0, exponential x, okay, minus 0, I0 minus 1. So this return to 0, and our I naught will be equals to x raised to power 0 exponential x, and which is the same thing as 1 multiplied by exponential x. So our I naught is equals to exponential x. Now, because there will be a constant of integration, we say that I naught is equal to exponential x plus c, but which that can be neglected for now. So we have evaluated I naught. We will now substitute the value of I naught into I1, and we substitute the value of I1 into I2. So let's rewrite the expressions for I naught, which is exponential x, I1. The expression for I1 is x exponential x minus I naught, and the expression for I2, which is the question itself, is x squared exponential x minus 2I1. So let us evaluate I1 now. I1 is equals to x exponential x minus I naught, and I naught is what? Exponential x. So let us substitute I1 into this, and our I2 will become x squared exponential x minus 2 into I1, and I1 is x exponential x minus exponential x. And this will give us x squared exponential x minus 2x exponential x plus 2 exponential x. So factorizing with exponential x now, remember that we are going to add plus c as the constant of integration. So we have that this factorized with exponential x, we have x squared minus 2x plus 2 plus c. And we recall that I2 in the question itself is integral of x squared exponential x dx. So therefore, the answer to the question we say is integral of x squared exponential x dx will be equals to this. In our next video, we'll be taking taking a look at another example to use reduction formula to evaluate the form of integral of x raised power n exponential x with respect to x.